Galileo Sky Tracking Units support CAN interface. This allows you to track up to 60 real-time parameters of the vehicle. However, to read the data, it is not enough to simply connect the device to the car's CAN bus. You need to determine which identifiers of the CAN bus protocol contain the necessary information. It is not always possible to get this information from the manufacturer because there is no common standard. Experimentally, we have set up an algorithm to find out what identifiers transmit the necessary information. Let's consider the algorithm in the example of defining fuel level. You can find details of presetting steps of CAN bus connection and scanning parameters in the user manual from our site. Connect the tracking unit to the CAN bus and laptop with downloaded Configurator Service program, and then turn the ignition on. Pay attention that while the CAN bus data are being transmitted, it is preferable not to perform any actions with the car. Open or close the doors, start the engine, enable the climate installation, and so on. First, on the CAN Settings tab, click Listen CAN. Scanning the CAN bus will result in a set of identifiers that includes fuel level data. Save this information to a file. Repeat the steps of CAN bus listening and saving the data. Fill 1/4 of the fuel from the whole tank volume. In our example, it will be 10 liters. Again, listen CAN 2 times and save the data to a file. Then, add another 10 liters of fuel in the fuel tank and repeat the operation of CAN bus listening. We've got 6 files altogether. Now process the received data in a special service program, WinMerge. Compare the initial files with each other before refueling and find the identifiers that do not vary in time. The unchanged identifiers in this program are not highlighted. Copy these identifiers in a separate file. Next, compare the 2 files after the first 10 liters refueling and redefine the identifiers with the same values. Check if the identifiers that we've received in the first comparison remain unchanged. It turns out that identifier 795 has changed, so we will remove it from our list. Then, compare the 2 files after the second refueling and redefine the identifiers with the same values. Compare with the list. We found no changes. In the next step, compare the data of one of the files before and after the first refueling. Now we compare unchanged identifiers with our list. From the whole list of identifiers, only one 612 has changed. We can assume that this identifier displays the fuel level data. To check the assumption, let's compare one of the files after the first and after the second refueling. We can see that identifier 612 has changed again and only 1 byte has changed. It means that it contains the fuel level information. Note that the fuel level data in other vehicles may be in 2 or 4 bytes. Now let's continue the analysis. The identifier has transmitted the values. 17 is before refueling, 28 is after the first refueling, and 39 is after the second. The CAN bus data are presented in hexadecimal format. To convert the values in decimal format, you can use the standard Windows calculator in the programmer mode. Here we write 17 in hexadecimal format and convert it to decimal format. As a result, the initial fuel level in a tank was 23. After the first 10 liters refueling, it became 40. After the second refueling, it rose up to 57. Therefore, in our case, 17 is the level of 10 liters of fuel. According to the received values, you can interpret the CAN bus information from the monitoring server. Note that for different car brands, the resulting parameters can mean different values. The last thing you have to complete is to match the found data to one of the tags of Galileo Sky protocol to transmit the data to the monitoring server. As the fuel level information is transmitted in 1 byte of identifier 612, we will bind this byte to 1 byte tag of Galileo Sky protocol. Then, we go to Protocol tab and tick the necessary tag. Click the Apply button. At this point, the algorithm of defining CAN bus data of fuel data and settings of Galileo Sky tracking unit are completed.